video is going to be on EE3. This is going to cover the scientific notation. Basically, scientific notation is going to be used to take either extremely small numbers and write them in an easier to read format, or take extremely large numbers and write them in an easier to read format. So essentially all we're doing is trying to eliminate all the extra zeros by changing it to an exponent. Alright, so let's go back just a little bit. If we give you like a percentage, say if I give you 24%, right? We've talked about this in class, but you know that percentages are going to be based on 100. And if you ever forget, you've got 2 zeros in your actual percentage symbol. So that lets you know that percentages are based on 100. Just like if you have 100% of a pizza, you've got the entire thing. If you've got 50% of the pizza, you've got half of it. Alright? So the way that we convert percentages over to decimals is we've got 2 zeros. That means we need to move our decimal 2 spots. So that would turn into 0.24. Alright? In a similar way, we're going to do something like that with our scientific notation. So if I were to give you a number like 2800000, okay, just making one up kind of based on what I see there. Alright, so that's going to be our large number. We've got 1, 2, 3, 4, 5 zeros that are there. Instead of writing out this insanely large number, what we're going to do is we're going to find all of the numbers that don't have a zero. So in this case, the only 2 numbers that we have are a 2 and an 8. Alright? The next rule that you need to remember is that you can only have one number to the left of the decimal. So between the 2 and the 8, I have to put my decimal there. If I put it there, I don't have any numbers to the left of the decimal. If I put it there, I've got 2 numbers to the left of the decimal. So the only place I can put it is in between the 2 and the 8. Scientific notation is always going to be based on a times 10 system, and that's because every time you move that decimal place, let me go over here. Every time you move that decimal place, you're actually multiplying it or dividing it out by 10 to make it move, because each column is a multiple of that 10. Alright? So now that we have our decimal, now that we know that we're multiplying it times 10, I can go back up to my original number and drop my decimal in there. On every whole number, I have a decimal over at the very end. So now I just need to count my spots over to know what my exponent number is going to be. So I'm going to go 1, 2, 3, 4, 5, and 6. I need to move it 6 places, so I have an exponent of 6. Alright? In a similar way, we can take a number that's extremely small, like 0.00000, that's that one more, 28. Okay? So again, we're using that same set of numbers, we're just sort of reversing it and putting our zeros in between the decimal and the actual numbers to make it a small number. So I'm still going to follow that same philosophy. I'm going to write down the 2 numbers that are not a zero. I can still only have one number to the left of the decimal. It's always going to be times 10, but now I need to figure out how many spots I have to move it to the right to get to that location. Alright? So again, all I do is mark it down here, and then once you get it marked here, you can transfer it back up and mark it in your actual problem. So 1, 2, 3, 4, 5, 6, and 7. So this would be a 7. Alright? There is one more catch to it. The way that you know if it's going to be moving your decimal to the right or moving your decimal to the left is by actually looking at what this number means. So if it's going in this direction, meaning that this number is less than 1, you're going to have a negative exponent. If you're going in this direction, meaning that your number is greater than 1, you're going to have a positive exponent. Alright? Now, based on all that we just looked at, that is how you write big numbers into scientific notation and small numbers into scientific notation. If you're actually going to be doing any kind of operations, this little thing right here is going to be your best friend. Alright, so we're going to bust out the handy dandy calculator, and we're going to let it do all of the work for us. So you still may have to do some conversions, but it's at least going to get us to the point to where it will tell us the answer. So let's start working through some of these questions. I think we've only got 7 or 8, so this video should be a little bit quicker than some of the other ones. Alright, we start off with the speed of particle A. It was measured at 2.8 times 10 to the 4 centimeters per second. Speed of particle B was measured at approximately 10 times the speed of particle A. Alright, so essentially they're telling us that we need to take the speed of particle A and we need to multiply it times 10. Alright, so I'm going to put my calculator up there. What you want to make sure you do always, and sometimes it works without them, sometimes you have to have the parentheses, but if you include the parentheses and you don't need them, you'll still get the right answer. So always include your parentheses. I'm going parentheses 2.8 times 10 raised to the 4th times 10. I'm going to hit enter. So that's going to give me 1, 2, 3, 4. 28 with 4 zeros. 1, 2, 3, 4. Alright, so this is where we have to do our conversion. I've got all the numbers that are not a 0, so I'm going to write those down. Have one number to the left of the decimal, so that tells me I need to put it in between the 2 and the 8. I'm going to transfer it up here so that I can know that when I say my times 10, I know where my decimal needs to go. Now with every whole number, you start off with your decimal at the end, and now we're just going to count over. 1, 2, 3, 4, and 5. So 2.8 times 10 to the 5th is the answer we're looking for. There's our 2.8 times 10 to the 5th. Alright, let's look at number 2. We've got what number is 7,500 times larger than 6 times 10 to the negative 6. So again, handy dandy calculator, going to hit clear. We're going to go parentheses, 6 times 10 rooftop negative 6. Once we get that typed in our parentheses, I'm going to have to multiply it by 7,500 because it tells us to multiply by 7,500. When I type that in, 0.045. Alright, so 0.045. Alright, so just like we did on this example, I'm going to rewrite my numbers that are not a 0. I can only have one number to the left of the decimal, and it's always going to be times 10. Okay, so now I know where I need to move my decimal to because I've already marked it down here in my answer. So I'm going to move it up to there, and now I just need to count over my spots. 1 and 2. So I'm going to have a 2. Alright, another thing with this, and if you'll notice you have a negative 2 and a positive 2. The number that we're starting out with, the one that we got in the calculator that we had to change, the 0.045, it is less than 1. So if this number is less than 1, I got to make it a negative 2. So that's going to give me answer choice C. Alright, let's look at number 3. A kilometer can be expressed as 1 times 10 to the 3rd meters, and a centimeter can be expressed as 1 times 10 to the negative 2 meters. Select the options that correctly complete the sentence. So we've got choice A blank, choice 1 is blank, choice 2 times smaller than a blank. Alright, so we need to go back and sort of interpret what they're actually asking. The first choice is how many times smaller than the second choice. Alright, so first go up and look at your actual numbers. We have a negative 2 and a positive 3. Alright, the negative 2 is associated with the centimeter. We've got the 1 and 10 to the 3rd that's associated with the kilometer. So a negative 2 is less than 3, so that means a centimeter is less than a kilometer. So centimeter less than kilometer. And now this takes us to this fun part. This is going to be what you see over and over again. If it says like times smaller, times larger, all that kind of stuff, this is your signal that you need to divide these out. Alright, so we always want to put our largest exponent in first, and then we're going to type in our smaller one second. So in the calculator, I'm going to parentheses 1 times 10 raised to the 3rd divided by parentheses 1 times 10 raised to the negative 2, and I'm going to hit enter. And that should give us a 1 with 1, 2, 3, 4, 5 zeros. There's my 1, 1, 2, 3, 4, 5 zeros. Okay. The other way you can do this, and this is kind of unique to this problem because we have a 1 times 10 in both of the examples. The other way you can do this is just know that every time you move it, you're actually adding a 0 to it. So the distance between a positive 3 on a number line and a negative 2 on a number line, that's 5 spots. So that should give us our 5 zeros as we go across. Okay. But realistically, I'd much rather you take the extra 20 seconds, type it in, hit enter, make sure you get it right. Alright, let's look at number 4. Which number is half the size of 8.7 times 10 to the 4th? We're going to represent that half with a 0.5, or you could represent it with a fraction and say 1/2, but we're going to say parentheses 8.7 times 10 raised to the 4th. We're going to multiply that by 0.5 and hit enter. So 43500. Alright, let's go back to our conversions. We're going to write down all the numbers that are not a 0. 435. How many numbers can I have to the left of the decimal? You said just one, you got it right. It's always going to be times 10. So now I need to transfer this decimal up here so I'll know where to move it to. So I'm going to go 1, 2, 3, and 4. Alright. Because that number is greater than 1 to start off with, that means I need to have a positive 4, so my answer is going to be looking like answer choice D. Alright? Alright, so that's going to take care of our first 4 questions. Alright, number 5. We're past the halfway point. We got a physicist measured the speeds of 3 particles as shown in the chart below. We got X, Y, and Z. We got 5, 3, 4, so that's the biggest, second biggest, that's the smallest. About how many times greater is the speed of particle X than particle Y? Okay, so here's your signal. How many times greater? So that's just like how many times smaller on the previous page. Whenever you see wording like that, that's your signal to divide it out. Alright, so we're looking at particle X, which is going to be 3.6 times 10 to the 5th, and we're looking at particle Y, so 2.4 times 10 to the 3rd. Alright, and just be careful with these. Remember, your larger exponent, that needs to go in the first one, and you divide it by the smaller exponent. Alright, so in my calculator, make sure you don't leave anything out. Parentheses, 3.6 times 10 raised to the 5th, divided by parentheses, 2.4 times 10 raised to the 3rd, close parentheses. It's going to give us 150. So we end up with 150. So if we want to convert this one over, again, find all the numbers that are not a 0. That's 1 and 5. I need to add my decimal. One number to the left of the decimal. It's always going to be times 10. Bring my decimal up there. Decimal of the whole number is always to the right side, and count it over 1 and 2. Right? Because that's going to be a larger number than 1. When we started off, it was 150. It's going to give me a positive exponent. So I need 1.5 times 10 squared. So that's going to take care of the first part of answer choice, or part A. Alright, for part B, particle W is found to be about 100 times faster than Z. About how fast is particle W? So we don't actually have a W in the list, but we do have a Z, and a W is going to be 100 times faster. So I just need to multiply those out. So 8.1 times 10 to the 4th in parentheses times 100. Alright. 8.1 times 10 raised to the 4th. Forgot my parentheses. Back over here. Second, insert parentheses. Head back over to the right side, and it was times 100. I'm going to hit enter. So 1, 2, 3, 4, 5. So 8, 1, 1, 2, 3, 4, 5. So 8,100,000. Alright, so now I need to take that and I need to do a conversion. It's either got to be to the 6 or the 400. I don't think I can move it 400 times, so let's work it out just to make sure. Copy down all the numbers that are not a 0. Always times 10. And now that I have my decimal, I'm going to mark it there in between the 8 and the 1. Mark it at the very end. 1, 2, 3, 4, 5, 6. So we should come up with 8.1 times 10 to the 6. Give me answer choice C. Alright, let's look at number 6. Right, in a laboratory, biochemists measured the mass of bacterium K is 5.6 times 10 to the negative 8. Measure the mass of bacterium J is 2.8 times 10 to the negative 7. Which of the following statements correctly relates the masses of the 2 bacteria? Alright, so again, we need to focus on which one's going to have the larger amount. A negative 7 has a larger amount than negative 8. So I'm going to type these in. We've got parentheses 2.8 times 10 raised to the negative 7. I'm going to divide that out by 5.6 times 10 raised to the negative 8. It's going to end up giving me 5 as a whole number. So that's going to be answer choice D. Alright, number 7. Got what is the value of 5.74 times 10 to the 3rd expressed in standard numeral form? Alright, so we've got 5.74 times 10 to the 3rd. You know what? We could do that by hand. We could also 5.74 times 10 raised to the 3rd. Let's see what happens. Nope. 5740. So we don't even have to work that one out. So 5,740. If you wanted to work it out by hand, we know that we need to take our decimal and move it 3 spots. So we have 1, 2, add a 0, 3. So still 5,740. Alright, number 8. The circumference of Earth measures approximately 2.5 times 10 to the 4th miles circumference of the planet of Jupiter is roughly 2.75 times 10 to the 5th miles. Which statement is correct? So we are comparing these two circumferences, so it's very similar to one of those questions like how many times larger, how many times smaller is one than the other. So we're going to find our largest exponent, 10 to the 5th, and we're going to divide that out by 2.5 times 10 to the 4th. Alright, so let's use our parentheses. So parentheses, 2.75 times 10 raised to the 5th divided by parentheses 2.5 times 10 raised to the 4th. So this is just an 11 as a whole number. Alright, so alrighty, so we're going to mark off the 1.1. We know that's out. We're going to mark off that 1.1. We know that's out. We just need to take our 11 and make it be times 1. So going back to your exponent rules, you'll know that anything to the 0 power is always going to equal 1. So it's kind of tricky how they wrote the answer, but B is going to be our answer. Alright, so that's going to wrap up our scientific notation. Just remember, if you're doing a conversion, you need to write down all the numbers that are not a 0. After you do that, you need to realize that it's times 10. And then after you do that, mark your decimal with only one number to the left of the decimal and count over either to the right or the left to get your exponent. If that starting number is greater than 1, it's a positive exponent. If it's less than 1, it is a negative exponent. So kind of the same thing that we did right in this box. We were kind of recapping all that. Alright, if you have any questions about this, just make sure that you find me in class. We can talk about it, get you caught back up, and we need to get all those tests made up.